Welcome, Math 10, to your first lesson in trigonometry. Today we are going to look at something called trigonomic ratios. So to start off, I have a little warm-up here. We're going to look at this triangle here and find the trigonomic ratios of BA or AB over OA. Okay? So we have many little triangles here where the angle is 25 degrees. This triangle here is similar to this triangle here, which is also similar to this triangle here, which is similar to this triangle here. If I look at that, all of these have one angle of 25 degrees, and if this is 25 degrees, this angle here is going to be the same as this angle, and this angle, because these are all right angle triangles. Okay, this is all 90 degrees. So if that's 25, these are going to be 55 degrees. 55, 55, and 55. Okay? Now, what we want to know is what is the side opposite of the right angle, right? So the side opposite divided by the side adjacent to the right angle. This here is going to be adjacent, the side that touches it. Opposite is far way away, okay? So let's see what we end up getting. So let's measure each one and see what the ratio is. So first we want the opposite divided by the adjacent, see what the ratio of those are. So here I look at it, I get 1.1. And we're going to divide that by, let's see, OA is 2.3. Okay? Now let's take a look at my next ratio. We have this next vertical, which is the opposite of the angle 2.5, because now we're looking at this triangle here. Okay? So I want this here, which gives me a total of 2.1, I believe, or not quite, go down, 1.9. And we're dividing by, here I'm going to end up getting 4.1, I think. Okay, now let's take a look at my next one. Here, I end up getting 3.2. And I'm going to divide that by 6.7. Okay, and we're going to look at my last ratio. Let's see what that is. We have, go over here, I'm going to get 4.1, and that's all over, say around 8.5. Okay, so let's see what all of these ratios are on our calculator. So let's check them out. We're going to have 1.1 divided by 2.3, which gives me about 0.48. This gives me 0.48. My next one is going to be 1.9 divided by 4.1, which gives me 0.46. Okay, well, that's a little bit off. Let's take a look at my next one here. 3.2 divided by 6.7. Which ends up giving me 0.48. My last one here, we're going to have 4.1 divided by 8.5, which gives me 0.48. Now I look at this one here might be off a bit because we're going by eye here, and I could be off by, it could be like this could have been 4.05, or it might have been 4.0, I could have measured slightly wrong. But in general, I look at this, the ratio, if the angle is the same, the ratio of the opposite divided by the adjacent side of the triangle, and a right angle triangle to the angle, are more or less the same no matter what. Okay, so they are the same ratio. Let's try the next one here. See if it's true for a different triangle with angle 55 degrees. Once again, I look at this triangle here. It's going to be similar to this triangle here. They have the same angles. This angle, if this is 55, this angle here would have to be 25. This angle here would have to be 25. Okay? So it'd be very similar. So let's try it out. We're going to go my opposite, right there, opposite divided by adjacent again. Let's measure what those are. So let's find my opposite first here. I end up getting 1.5. Okay? So let's see what we get. Get 1.5 divided by, it's here, we're going to end up getting 1.1. Okay, let's take a look at my next one. I have 2.7 approximately, and then we're going to divide it by 2. So I have 2.7 divided by 2. And take a look at my next one here. We're going to get 4.2, and we're going to divide that by 3. And we're going to look at one more. To get, take a look, 5.6 it looks like. Yeah, 5.6. And that's going to be divided by here, 4. Okay, so let's put these all into my calculator. I'm going to end up getting 1.5 divided by 1.1, and I get 1.36. So 1.36. Let's take a look at the next one. 2.7 divided by 2, and we get 1.35. These are beginning to be very close. Let's take a look at my next one here. 4.2 divided by 3. Ooh, 1.4. And then my last one, 5.6 divided by 4, I get 1.4 again. Okay? So basically, if I round off, remember, it's kind of, we're doing handwork here, so my eye could be off a bit. I am old. Or it could be many other mistakes with my measuring, but in general, they are all about the same ratio. The opposite over adjacent is always the same for the angle, okay? And these are similar triangles for each triangle. So no matter, if we have an angle then, we could use that to find out my ratio of opposite and adjacent, the ratios of the sides of my triangle. So this could also help us discover heights of buildings, heights of mountains, and stuff like that. Okay? So, here is just some definitions that we have to do. From angle X, OA is my adjacent. Okay? BA is my opposite. Okay? And then we have OB is my hypotenuse. Okay? So there we have our 3 definitions that we need to know. So here's a ratio we need to memorize. So sine x, if I'm looking at sine of my angle, of angle x, that's always equal to opposite over, normally just related as O, over hypotenuse. Okay? Cosine of the angle x is equal to adjacent over hypotenuse. And tangent of the angle x is equal to opposite over adjacent. So another way of doing this is sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. So a way of remembering it is so, ka, toa, or so, ka, toa. And that is your general trigonomic ratio. So for sine, whenever we're looking at sine, we're looking at the ratio of the opposite divided by the hypotenuse, okay? For any angle, for a certain angle. So if I'm looking at this angle here, this now becomes the opposite and this becomes the hypotenuse, or the adjacent. And the hypotenuse is always the longest side, which is opposite of the right angle. Tangent, or the adjacent, is always going to be the one that touches the angle, okay? So, here we go. Let's look at SOHCAHTOA, okay? Find the sine ratio for this one here. For angle A, we want to find the sine ratio. Well, the sine ratio is going to be opposite divided by hypotenuse. So we have my opposite of 20 divided by 29. Opposite is always the one directly across. It's the side that's not touching the angle, okay? Now we want to find the cosine ratio. Cosine is adjacent divided by hypotenuse. Well, the adjacent is the one touching, so that's 21. And the hypotenuse is, well, the side always opposite the right angle, over 29. Last one is tangent. That is opposite over adjacent. So I'm going to go 20, the opposite of the angle, over adjacent, which is 21, the one touching the angle. Okay? That's it. Those are my ratios. So now, complete and write in simplest form. So we want sine theta. Okay? So we want sine is always opposite over hypotenuse. So I go, my opposite is 30, my hypotenuse is 34. So that's 30 over 34. We want cosine theta. So that's adjacent divided by hypotenuse. So we have 16 all over 34. Both of these could be simplified. This is 15 over 17. And this here is 8 over 17. Okay? Now the next one here is tan. So it's going to be 30 is opposite is 30 over 16. Okay? And that will give me 15 over 8. Simplified. Okay? So those are my ratios. And I put them in simplest form. Okay? Let's try my next one here. We want sine of angle theta. Well, I look at this question. There's no theta. Well, I know this is 90 degrees, so it's never going to be the right angle. And I know this is an isosceles triangle, so that means this angle and this angle must be equal. So sine theta, if this is theta, then this here is theta. They both must be equal because it's an isosceles triangle. So sine theta is opposite over hypotenuse. So that's 1 over root 2. Okay? That's as simplified as we could get until later we'll learn how to rationalize. Now cos theta is the same thing. Well, it's this divided by root 2. So it's 1 over root 2. Because my opposite and adjacent are equal for this one. Now the last one is tan theta, which is going to give me 1 over 1, which is equal to 1. Okay? Because they are the same. So it's just equal to 1, the ratio. Okay? Here we go. Now it wants us to complete these following ratios. So we want sine of x. So we're looking at x. Now what is sine is opposite. Remember, so katoa. So let's write that always on top. So ka toa. We want sine is opposite. There we go. Opposite over hypotenuse. So my opposite is right there. My hypotenuse is here. But we don't know what the hypotenuse is. So let's find the hypotenuse. Remember the Pythagorean Theorem? C squared is equal to a squared plus b squared, which will give me 3 squared plus 4 squared, which is the same as 9 plus 16, 25, square root to get c, which gives me 5. So I know 5 is my hypotenuse. So this here is 5. And I want opposite over hypotenuse. That's going to be 4 over 5. Okay? Let's take a look at my next one. Now we're looking at tan x. So tan is opposite, is going to be opposite over adjacent, because we're looking at TOA. So that's going to be 4 over 3. Next one here is tan y. Now we're going to look at this one. The opposite of y is this 3, right? It's all the way across. So we have 3 all over, adjacent is 4, so the one touching. Okay? Now cos x. Cos is ka. Okay? So adjacent over hypotenuse. For x, the adjacent is 3. The hypotenuse is 5. Always the longest. Hypotenuse is always opposite of the right angle. Next one is cosine y. So, we have y, we want adjacent, which is 4, all over my opposite, which is 5. And that's it. Okay? So this next one here is the same idea, except now we have 5, 12, and 13. Still right angle triangle. First one wants cosine A. So we're looking at this angle here. Cosine is ka, adjacent, over hypotenuse. So the adjacent is the one touching, which is going to be 5. My hypotenuse is 13. Okay? Next one is, we want tan A. So tan A is going to be toa. So ka toa. So to is going to be opposite over adjacent. 12 divided by 5. And now my last one is cosine B. So here's angle B, and I want adjacent divided by hypotenuse. So it's going to be 12 over 13. Okay? Kind of interesting. So, that is everything for our trigonomic ratios. Hopefully you understood that. Good luck as we work on this tomorrow together as a class.